answers in about. Hi, this video is about the agentic loop. We are still in the action layer, and this is where things get genuinely powerful. If tool calling from the last video is one action, an agentic loop is unlimited actions working toward a goal. By the end of this video, you will have a working agent that can plan and execute multi-step tasks autonomously using any of the three providers. So, what is it? Tool calling is a single decision. The AI picks a tool, your code runs it, the AI answers, done. An agentic loop is tool calling running repeatedly in a cycle. You give the AI a high-level goal and a set of tools. The AI plans the next step, calls a tool, observes the result, and then decides what to do next. This repeats over and over until the AI decides the task is complete. The key difference from everything we have built so far is autonomy. The AI figures out the steps on its own. You do not write a step-by-step plan. You give the goal. The AI navigates to it. Think of hiring a researcher and telling them to write a competitor analysis report. You do not give them a checklist. They decide what to search for, read the results, take notes, search more, organize their findings, and write the report. They work until it is done. An AI agent does exactly this, using the tools you provide. Next, workflow. The workflow has 5 steps that repeat in a cycle. Step 1. The user gives the AI a high-level goal, something like search for the latest Python news and save a summary to a file. Step 2. The LLM plans the next single action. It thinks through what information it has, what it still needs, and which tool would be most useful right now. Step 3. The AI calls that tool. This is the same tool use block from video 6, a structured decision about which function to run with what inputs. Step 4. Your code runs the tool and appends the result to the messages list. The messages list is the agent's memory. Every tool call and every result that has happened so far is stored there. On the next iteration, the AI reads this complete history to decide what to do next. Step 5. The done check. You look at the stop reason field in the response. If it says end turn, the AI has decided the task is complete. Return the final answer and exit the loop. If it says tool use, the task is not yet done. Run the tool, append the result, and go back to step 2. Look at the 2 outcome boxes at the bottom of this slide. The green box shows what happens on completion. Stop reason is end turn. Return the answer, exit the loop. The red box shows what happens when more work is needed. Stop reason is tool use. Run the tool, add the result to memory, and loop back. The tip at the bottom is the most important safety rule in this entire video. Always set a maximum iterations limit of 15 to 20. An agent that gets confused or encounters an unexpected error will loop indefinitely without this limit. In production, an uncapped agent can exhaust your API budget before anyone notices. Next, key concepts. 3 things to understand deeply. First, the loop mechanics. The loop is a simple Python for loop with a maximum iteration count. On each pass, you call the API with the full messages list. If stop reason is end turn, you break out and return. If stop reason is tool use, you run the tool, append the result to messages, and continue to the next iteration. The core logic fits in about 20 lines. Second, memory as the messages list. The agent does not have a special memory system. Its memory is the growing list of messages you pass to the API on each call. Every user message, every AI response, every tool call, every tool result is appended to this list. When you make the next API call, the AI sees the complete history of everything that has happened and uses it to plan its next action. This is why the agent knows what it has already done and what still needs to be done. Third, LangGraph versus a raw loop. A raw loop is sufficient for learning and simple tasks. For production, LangGraph adds several critical capabilities. Checkpointing saves the agent's state to a database so it can be paused and resumed across sessions, even after a server restart. Thread ID is a unique identifier for each conversation or task that LangGraph uses to store and retrieve checkpointed state. Human in the loop is the ability to pause the agent before a risky action, like sending an email or deleting a file, and require a human to approve it before continuing. Graph visualization lets you see the agent's complete decision graph, which makes debugging much easier. Next, project setup. Install Anthropic, OpenAI, LangGraph, LangChain Ollama, LangChain Core, and Python.env. LangGraph is a separate package from LangChain. Install it explicitly. Start with a simple, predictable goal when testing. A goal that requires 2 or 3 tool calls is ideal. Something like search for Python news and save a summary to a file. This is easy to verify because you can check whether the file was created and whether its contents make sense. Do not start with open-ended goals like research everything about artificial intelligence. The agent will make dozens of tool calls, spend a lot on API costs, and may never reach a satisfying stopping point. Always test your tool functions individually before connecting them to the agent loop. If a tool crashes inside the loop, the error message appears as a tool result in the messages list, which is harder to diagnose than a direct error in a test script. Next, agent Anthropic.py. The Anthropic raw loop implementation has 4 parts. First, the tool definitions. Same format as video 6, a list of dictionaries with name, description, and input schema. 3 tools: web search, write file, and read file. Second, the run tool dispatcher. Same pattern as video 6, a function that routes tool names to their Python implementations. The tools here are simulated. In a real application, you would replace the web search implementation with an actual search API call. Third, the run Agentic function. It takes the goal and a max iterations parameter. It creates the messages list with the user's goal and iterates up to the maximum count. On each iteration, it calls the API, appends the response to messages, checks the stop reason, and either exits or runs the tool and loops. The print statements inside the loop are intentional during development. Printing the iteration number and each tool call makes it easy to follow what the agent is doing. You can remove them before production. Next, agent OpenAI Pi. The OpenAI version is nearly identical in logic. The differences are in the tool format and the completion check. OpenAI uses the same function envelope format from video 6, each tool wrapped in a type equals function dictionary. The completion check is different. Instead of checking stop reason, you check whether the message has tool calls. If the message has no tool calls, the agent is done. The tool execution loop reads the arguments as a JSON string using JSON.loads, because OpenAI returns arguments as a JSON-encoded string rather than a dictionary. The run tool dispatcher stays identical. You never need to touch your actual tool implementations when switching providers. Next, agent Ollama.py with LangGraph. The Ollama implementation uses LangGraph, which is the recommended approach for production agents. A graph in LangGraph is a set of nodes and edges. A node is a step in the workflow, in this case, 2 nodes, agent and tools. An edge defines how execution flows between nodes. A conditional edge is an edge where the next node depends on the current state. The tool's condition function automatically routes to the tools node when the AI returned a tool call, and to the end node when it did not. The tool's condition function is built into LangGraph. It reads the last message in the state and checks for tool calls. If found, it returns the string tools. If not, it returns end. This replaces the manual stop reason check from the raw loop. The bind tools method attaches the tool definitions to the LLM, so every call automatically includes them. The compile method assembles the graph into an executable agent. The tool node handles the tool execution automatically. You do not need to write a run tool dispatcher. It looks up the function by name, calls it with the provided arguments, and appends the result as a tool message. Next, LangGraph with checkpointing. This slide shows 2 production features, checkpointing and human in the loop. Checkpointing means saving the agent's complete state, the full messages list, the current position in the graph, and any variables, to a storage backend after each step. If the server restarts, or if you want to resume the task later, you can pick up exactly where you left off. Memory Saver stores checkpoints in memory. This works within a single server process, but is lost on restart. For production, SQLite Saver persists checkpoints to a SQLite file, and Postgres Saver uses a PostgreSQL database. The thread ID in the config dictionary is the unique identifier for this conversation. LangGraph uses it to store and retrieve the checkpoint. 2 runs with the same thread ID share state. 2 runs with different thread IDs are independent. Human in the loop is enabled by the interrupt before parameter on compile. The value is a list of node names to pause before. In this example, interrupt before tools means the agent pauses before every tool execution. When the agent pauses, it returns the current state, including what tool it wants to call. A human can review this, approve it, or cancel. To resume, you call invoke with none as the input and the same config. LangGraph loads the checkpoint and continues from the pause point. Next, Fast API endpoint. The Fast API endpoint exposes the agent as an HTTP API. The task model has two fields, goal and max iterations with a default of 15. The route handler runs the same raw loop from the Anthropic implementation. The key addition is the log list, which records every tool call, what was called, with what inputs, and what result was returned. This log is included in the response. The log field is the most important addition for a production agent endpoint. It gives the client full visibility into what the agent did to produce the answer. This is useful for debugging, for audit logging, and for showing users how their request was processed. The iterations field tells you how many cycles the agent needed to complete the task. If you regularly see it hitting the maximum, your goal descriptions or tool implementations may need improvement. Next, common errors. If the agent loops forever, your max iterations limit is missing. Always set it. Return a graceful message when the limit is reached. If the agent repeats the same tool call with the same inputs, add a system prompt instruction telling it not to repeat calls it has already made. If a tool crashes inside the loop, wrap run tool in a try except block and return an error string. The agent will read the error and adjust its plan rather than crashing entirely. If the agent goes off track and ignores the goal, restate the goal in a system prompt. Add an explicit instruction to stay focused on the original task. If a LangGraph graph never reaches end, the LLM is always returning tool calls. Check that your tool's condition is correctly imported and that the LLM actually stops calling tools when done. If a memory saver checkpoint is not persisting between server restarts, that is expected behavior. Memory saver is in memory only. Switch to SQLite saver for persistence. If the agent is using too many tokens and becoming expensive, summarize early tool results periodically. After 10 or so messages, replace older tool results with a one-line summary to keep the context window manageable. Next, takeaways. An agent is a language model plus tools plus a loop that continues until the task is done or the maximum iterations are reached. The AI plans each step autonomously based on the goal and what it has already done. You give the goal, not the steps. The agent's memory is the growing messages list. No special memory system is needed for basic agents.
Always set max iterations between 15 and 20. Always wrap tools in try except.
These two practices prevent runaway agents in production. Use LangGraph for production. It adds checkpointing for pause and resume, human in the loop for approval of risky actions, and graph visualization for debugging. Next video is Async Job Queue, where you learn how to run slow agent tasks in the background without blocking your web server.